Hello everyone, this is Kalema Alan, and I'm here to talk about how machine learning can be implemented in the heart disease detection system. This is a project I decided to stumble upon because in Uganda, there is an increased rate of heart diseases due to the change in diet over the past few years. So as a computer science student, I decided that come up with I could come up with a system that can actually detect any heart disease early enough so that we can actually get up to speed with medication. So, so brief overview about machine learning. Machine learning, this is an artificial intelligence that focuses on developing models and, and allows computers to learn and improve with experience without being explicitly programmed. So what I mean by this is uh, a machine can be, what I mean by this is a machine, you write an algorithm, you feed it to a machine, and it will be able to perform different tasks without learning from experience. That algorithm teaches the machine using, of course, data sets, and it will be able to perform other tasks that are closely related to what you taught it with without being actually reprogrammed. Machine learning in general has three types. There is supervised, there is unsupervised, and there is reinforcement. And you're going to talk about it. We are going to talk about each in the next few slides. So according to our work, this is the wait a bit. This 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 is our illustration. First of all, from the start, you collect the hard disease data set. The data set can be the, for example, someone's name, age, weight, and all that. You extract significant variables from the data. You process it. You split the data into the one you're going to use for training and the one you split the data and you put it into a training mode. And in training, we have models you can use like the KNN logistic, we have regression, and we have the random forest classifier. We're going to talk about all those. After training the model, you introduce the testing bit. You introduce the data that you can use for testing. And if the model passes the testing phase, you actually, because by passing, I mean it will identify those that have a heart disease and those that are normal and proceed. So the project idea, as I've talked about, it involves a heart detection system. Machine learning plays a role in analyzing and interpreting medical data to predict the likelihood of a person having a heart disease. Yeah, so the significance of a project enables the system to learn patterns and relationship from historical data. Remember, we are going to be feeding it data and it will be able to learn from the data, aiding in accurate prediction and detection of heart diseases. The system can adapt and improve prediction over time as it encounters more data. As I said, you're teaching the algorithm something, contributing better diagnostic capabilities. Okay. So we have supervised learning. Supervised learning as a form of machine learning. And this involves training a model with a labeled data set, where each input is associated with a corresponding output. The algorithms learn mapping between inputs and output. So we have examples of supervised learning. Supervised learning, we have classification and regression. Here, classification is, you can explain classification well using the emails and spamware, and where an algorithm is fed different kind spam emails so that it can be able to collect the keywords and use those to predict any other spam email that might come in. Yeah, and here we also talk about classifying objects in images such as cats and dogs, whereby initially you've been feeding the algorithm with pictures of cats and dogs, and so that it can be able to to class, you can be able to identify them in other images that you feed them into. Then regression is predicting a price of a house, for example, predicting a price of a house based on the features like square footage. So I've explained this earlier, but this is in relation to other, of course, our project. We have the CSV data set. That's the information data set for the heart disease or patient data set. Here it will be processed so that you can remove incomplete data and, you know, noise data, as they call it. You train, you use the, you pick out a set of data to train the models. We have the decision tree, we have the random forest, we have the KNN. You train those models, and then you feed it an extra data for testing. And if it passes in under model evaluation, then you have to evaluate the prediction. So here decision trees are being talked about, and I will just pass through briefly. Imagine where you answer a series of yes or no questions to reach a final destination. In this case, decision tree is whether the patient is likely to have a heart disease or not. So you have a yes or no question scenario, and at the end, the answer you take or the path you take in a decision tree will determine the answer you get at the end. So we also have the random forest. These are the models we were training. Random forest is like a group of decision trees. Where decision trees, different decision trees. Okay, it's a symbol method that builds a multiple decision trees that combines their predictions to improve the accuracy and reduce overlifting. So this provides a more accurate answer because different decision trees are put in place, bigger decisions. There are more decisions that are made to come to an answer. So we have the naive Bayes. This calculates the probability of each class given the features and assigns the class with the highest probability. We have the support vector machine. As mentioned in our project, this demonstrates high accuracy in heart disease detection. Remember, it's a supervised learning algorithm used for classification and regression tasks. So types of problems. The primary problem in the heart disease detection project is classifying whether the patient is at risk of heart disease or not. The algorithm will learn to categorize these patients into different classes based on their features. Now, how labeled data will be used? Labeled data will consist of historical patients' records, where each record is associated with a label indicating the presence or absence of a heart disease. Features like age, blood pressure, heart, ECG results, and blood sugar will be used as inputs, and the corresponding label will be the output. In other words, there will be certain values, there will be a threshold of values on these different what do they call them, on these different parameters, in that you'll be feeding a computer and that a person, if a person is under, let's say 30 years, is above 30 years, and he has this kind of blood pressure, or he does this kind of work, this is his diet, there's a likelihood of having a heart disease. And that's what they mean by labeled data. The supervised learning algorithm will learn the underlying patterns in the labeled data, creating a model that can predict the likelihood of a heart disease for the new and seen patient data. Yes. So under unsupervised learning, remember, unsupervised learning deals with unlabeled data, aiming to find patterns, structures, or relationships within the data without explicit guidance. It's exploratory in nature. In other words, they just give you input raw data. The data is disorganized or raw, as they say it. So the algorithm must be able to get that data and process it, identify, classify it on its own into different categories, and then release an output. Examples of this, we have the clustering, where there's a grouping of similar documents together based on their content with prior categorization, grouping similar documents together based on their prior categorization. That is clustering. So application of that in our project. Unsupervised learning may be used to identify hidden patterns or clusters within a patient's data. It can help discover relationships between parameters without predefined labels. Remember, I mentioned about what labels are. So potentially revealing new insights to the characteristics of a heart disease. Since you don't actually put labels on the different parameters or the different data of a patient, the machine itself will innovatively be able to categorize this so that it can be able to, so that it can spot out those slight things you might have missed in the labeling. Yes, I don't know if I can make it clear. So algorithms to be used. Remember the types of algorithms in unsupervised. We have clustering. So under clustering, there are types of patterns. There is identification of patient clusters. Clustering algorithm can reveal groups of patients who share the same common traits. Remember, it's categorizing data based on certain traits without formal organization. So share common traits. These groups may represent different risk profiles or subtypes of the heart disease. Then we have dimensionality reduction. This is another form of unsupervised learning. So in this, the type of patterns is reduce dimensionality insights. Dimensionality reduction can help in visualizing the data in a low-dimensional space, potentially highlighting features that contribute to the most heart risk. Then handling unlabeled data. The heart disease detection project may involve sharing large data set with a variety of patients' information, some of which may not have explicit labels indicating a heart disease status. Unsupervised learning allows the algorithm to explore the inherent structure of the data, making it suitable for situations to be handled, situations where labeled data is limited or unavailable. So we have reinforced learning as the third type of machine learning. Then reinforcement learning involves an agent that learns to make decisions by interacting with an environment. The agent receives feedback in form of rewards or punishment based on the actions, guiding it to improve by time. Remember, all machine learning algorithms, all machine learning types or algorithms, they learn with experience. So in this, you leave the machine or algorithm to make mistakes. It learns from mistakes. It does decisions without guiding it. When it fails, it will know that this is the wrong path. Let me try this. Then it will go through that way and it will see if it gets a success, it will know, so this is the right path. And hence it's learning. So we have examples. There is game playing, of course, the environment, because in reinforcement, there is an environment, there's an agent, and there's a reward system. And then in the environment, there is a game board and rules. The player making moves, and the reward system, the agent is the player making moves, and the reward system is winning the game result.